Hello and welcome back. In this video tutorial, we're going to be taking a look at physics homework number 6. Now in PH number 6, we are now looking at an acceleration versus time graph. What do we need to know about that? Pretty much just, well, two things. One, you ought to be able to read the acceleration time graph for acceleration values at any given time. Okay, those are the first 4 questions right here. But what else do you need to be able to do? Well, as it turns out, the area under an acceleration versus time graph gives you the velocity. Now, specifically, it gives you the change in velocity, but for now, it'll give you what the velocity builds up to, especially if we are starting a car at rest with no velocity at time equals 0. Okay, let's take a look at this problem. If we see we're building up the car from rest, which means the car starts at 0 speed. Every 10 seconds, okay, now so our acceleration is 2 meters per second. So every second it's building up 2 to 4 to 6, 8, 10, 12, 14, 16. At the end of 30 seconds, it is built up, right, velocity from 0. Well, we can figure that out. We can figure out that velocity by finding the areas under. So I might suggest that you chunk these areas into pieces that are familiar. So for instance, there's one particular interval that we can find the area of. There's another interval there. You'll notice here it's acceleration 0. So what acceleration 0 means, constant velocity. Whatever velocity you built up to that point, it's constant velocity for 20 seconds. Okay. Now, negative acceleration just means, well, it could mean a couple things. So this over here is all positive constant acceleration. Here the acceleration is reducing to 0, but it's still positive. What does positive constant acceleration mean? Could mean two things. One, you're either so you're speeding up, going forward. Since we were told the car starts from rest, that most likely makes sense. We're speeding up, going forward. Because if you look at that, speeding up is a positive change in velocity, forward is a positive direction. The two of these together give you positive constant acceleration. Like I said, 0 acceleration means constant velocity, whatever you built up your speed to. And then down here, we have negative constant acceleration here. Well, what happened there? Well, clearly you're going to have a change in velocity, but that could mean a couple of things. It could either, this negative constant acceleration could either mean you're slowing down going forward, because slowing down is negative, forward is positive. Together they give you negative constant acceleration. Or you're speeding going backward. Both these combinations give you negative constant acceleration. Now, which one makes the most logical sense? You're starting at rest. What kind of makes sense to me in this problem is you started at rest, you built up speed, you kept that speed constant for 20 seconds, and then you slowed down to a certain point, all moving forward. So I think this is forward direction probably the whole way. That's my guess. All right, let's actually begin the problem. Okay, and I'm gonna erase some of this other stuff here that I don't need. All right. Now, number 1, what is the acceleration at 10 seconds? Well, we go to 10 seconds on the graph. We look and see at 10 seconds would be here. You can see we have an acceleration of 2 meters per second squared. So questions 1 through 4, pretty straightforward. We're just reading right off the graph. At 40 seconds, so at 40 seconds, we're here. We're at this part of the graph. We look over and, oops, I'm sorry. It's not there. 40 seconds would be right here. Looking over, we can see that that would be 1 meter per second squared. Okay, what is the rate of acceleration at 50 seconds? Well, 50 seconds is right here. That would put it here. You can see that's 0 acceleration at that point. Okay, what about at 85 seconds? Well, 85 seconds is right here. That would be at -3. So the first 4 questions, pretty straightforward. We're just reading off the acceleration from the graph. Okay, now questions 5 through 8 are going to require some area calculations. I have room right here to do the work because I'm not going to be able to squeeze the work into that small little spot, okay? Question 9, we're going to be sketching the velocity time graph here. And then finally, question 10, we're going to be calculating the total distance. We can do that work here or down here, wherever we have room, okay? So that's going to be the plan to finish out this question. All right, how do we figure out the velocity for the first 10 seconds? Well, that would basically be this. You're going to have this little rectangle right there to find the area of. So for number 5, the velocity, right, equals the area, which would be, this is a rectangle, mind you, so it would be 10 seconds times a height of 2 meters per second squared. You'll notice this cancels with this, leaving you meters per second is the proper unit, and you can see we end up with 20 meters per second. So again, just like before, there's minimal work to show, but we still need to show a little work. Okay, now what would be the velocity of the car after 30 seconds? Well, now, ladies and gentlemen, you're finding the slope, or not the slope, you're finding the area of this whole rectangle, because that would take you to 30 seconds. Okay, and then we're going a full 30 seconds times the same acceleration, 2 meters per second squared. That would give you a speed built up to 60 meters per second. So the car starts from rest, and after 30 seconds, it is built up to 60. And that makes sense because if it's 2 meters per second squared, 30 seconds, you're going 2 meters per second every second. So after 30 seconds, it makes sense that you have built up 60 meters per second of speed in that point, which equates to about a little over 120 miles per hour, just to put it in familiar terms. All right, so now we have part 7. What is the velocity at 50 seconds? Well, that would be to the end of this. So it's not just the area of this anymore, it's the area of all of that whole trapezoid. So we need to find that triangular area. So we know the velocity here is going to be the 60 meters per second from, that would be this rectangle here, plus the triangle, which is going to be 1/2. The base is going to be 20 seconds times the height, which is 2. 1/2 of 20 is, 1/2 20 is 10 times 2 is 20, plus the 60 would be 80 meters per second. So what we did is we built up speed from 0 to 80 meters per second in 50 seconds. What that also means, guys, is this is going to be a constant velocity of 80 meters per second for 20 seconds. You're going to keep that speed until you start slowing down. So this is the speeding up part from 0. This is going to be the slowing down part from, towards 0 again. You may not completely slow down, but you're going to slow down towards 0. All right, and then finally, we're finding the speed to 100 seconds. Okay, to 100 seconds. Now for here, we have to kind of add it up as we go. It's very cumulative. So now I got to start finding area on this side. Well, I got this rectangle here and this rectangle here. Okay, now that little skinny rectangle, that thing has a base of 5. Okay, so for this total speed, I have 80 plus, now that's going to be 1/2 because that's a triangle right there. So we're going 1/2 a base of 5 seconds times a height of -3. Okay, so it's basically what, half of 15. Okay, -7.5. okay? And then plus a base of, what is that, 25? 25 seconds? So from 75 to 100, that's 25 seconds. Okay, to -3 as well. Okay, and we can see what this adds up to. We have 80 plus a negative is just minus 7.5 minus 75. Well, add that up. And we have 80 minus 7.5 minus 75 is about -2.5 meters per second. Okay, now we're going to plot the velocities in a minute, but before we do, let's go ahead and jump on number 10. We have room for it down here. What is the total distance traveled in those first 30 seconds? Meaning, how far did you go to build up to 60? Well, one easy calculation we can do with that is delta x is equal to v plus v naught over 2 times t, where v naught was 0, if you recall. And so we're going 60 plus 0 over 2 times 30, which is going to be 30 plus 30, or 900 meters. Okay. Now, you could have used another calculation too. Didn't have to do that. You could have also gone x is equal to x naught, which started at 0, plus v naught t, which also started at 0, plus 1/2 at squared. And if you did it this way, you'd have 1/2. The acceleration for those first 30 seconds was 2. So 1/2 times 2 times 30 squared. Well, that cancels, and 30 squared is, what do you guess? 900 meters. So you have a couple ways of getting the 900. Make sure you're comfortable with that. All right, now we got to plot some velocities here. So the first, what we're starting with is we're starting with a velocity at 0. So we're going to plot points, then we'll connect these dots. So I'm going to start with a dot right here at 0. And at 50 seconds, I've built up to 80 meters per second. So we're going to go to about 50 seconds. Okay, so now you'll have the, this is probably going to be, till about 30 seconds. So about 30 seconds, you're at 60. All right, so let me see how we can plot this. How about we go, each box is 10. So it'll be 20, 40, 60, 80, something like that. That'll make it work, okay? And then down here, we're just at -20, -40, -60, -80. Okay, we can make that work. All right, so here we plot a point at 30 and 60. Go ahead and connect that with a dot. With a straight line. That's the first part. Now, at 50 seconds, you're at 80. Now, what's happening here is you're going to have a curve, and that curve is going to represent this decrease in acceleration right there. It's not constant anymore. Okay, now you have constant velocity for 20 seconds. So we're going to have a straight line across for that. Okay, now you've got a 5-second thing here where you are changing speeds. Okay, what are we changing speeds to? Well, that's -7.5. -7.5. So remember, that little area was -7.5. So we're at 80. So 80 minus 7.5 is now 72.5. So 70 is here. 72.5, that would be like maybe right there. So we're going to curve it down to there. And then the last thing we have to be able to do is, and this gets us to 100, you're going to plot your last one plot your last velocity at 100 seconds, and then we'll just connect it from there because you can see it's a straight line for the rest of the way. So at 100 seconds, you're at negative 2.5. That would, see, negative 10 would be here. Negative 2.5, I mean, like maybe right there. Okay, go ahead and connect those with a straight line, and there you are. There's our velocity versus time graph.